Hey everybody, let's do some factoring of trinomials. So I'm sure you've heard of factoring before, and you might have learned how to do this in multiple different ways. The point of this video is pretty much to show you how you unfoil, for lack of a better word. You've heard me say that foiling doesn't always make sense, and it doesn't always make sense. But in this term, we're just going to say you learned back in the day how to multiply two binomials and you would get a trinomial. Factoring is just working backwards. So what you're doing is you're unmultiplying. And what you basically have to do is think of two magical numbers. Now, this video is only going to talk about trinomials where the leading coefficient is 1. So the leading coefficient equals 1. That is the only type of factoring we're going to cover in this video. As soon as that leading coefficient is other than 1, this gets much more difficult. So what you're doing is you're thinking of two variables that will multiply to x squared, and it's just going to be x times x. That's the only way you can factor that. That's why this job is easy. But then you need to think of two numbers that will multiply to 6 and add to 5. So there's a couple of different ways I've seen people do this. Some list out all the factors of 6, but this one's not too difficult to think about. What are the only two things that'll multiply to a positive 6 and add to a positive 5? Well, you could try a 6 and 1, that would give you 7. You can try 2 and 3, and that would give you 5. So 2 times 3 is 6, but 2 plus 3 is 5. So you would have a positive 2 and a positive 3. Okay, and that's how you factor. Now, just to go back and show you, back in the day when you used to call that foiling, you would multiply the x times x and get x squared. And then you would say x times 3 is 3x, then 2x, and then 2 times 3 is 6. And then you would combine these two, 2x and 3x would add up to 5x. And that's how you ended up with x squared plus 5x plus 6. So what we did is we just worked backwards. We split up the 5x into two values that would add up to 5, but multiply to 6. Okay? But all that stuff is old school. Your answer for this first problem is x plus 2 times x plus 3. And I'm sure if you're slick with a graphing calculator, you can use that to your advantage to help you find those numbers if you were having trouble thinking of them. Like this next one, for example. What are two numbers that will multiply to a positive 12 but add to a negative 8? So when you think about that, of course we're going to have our x and x, but what two will multiply to a positive but add to a negative? The only way to multiply to a positive number is to multiply two positives, or, in this case, two negatives. So what two negative numbers would add up to a negative 8? That would be a negative 6 and a negative 2. Okay, and if you wanted, you can FOIL that to make sure that you get x squared minus 8x plus 12, but I can tell you for this one, that's right. No need to check, but you can if you want. So you have two more examples right here. I would like you to pause the video and try them, but what you're thinking of two numbers that will multiply to the negative 12 but add to a positive 1. And in this one, what two numbers will multiply to a positive 4 and add to a positive 5? Okay, pause the video, give that a try, and then we'll talk about it when you're ready. Click play. Okay. Obviously, we have x times x. That's going to give us our x squared. Now, what two numbers will multiply to a negative 12? In order to multiply to a negative, you need one positive and one negative. So what multiplies to 12? Well, you've got your 12 and 1, your 6 and 2, but you need to differ by 1 now. So we're going to need a positive 4 and a negative 3 to do that job. So 4 minus 3 is 1, but 4 times a negative 3 is a negative 12. So if you had x plus 4 and x minus 3, you are good to go. For the second example, you need to think of two numbers that multiply to 4 but add to 5. And that should have been very simple. X plus 4 and x plus 1, because 4 times 1 is 4, but 4 plus 1 is 5. Okay, so you thought you were done. I actually have two more for you. I want you to brainstorm these two. Go ahead and pause the video, try them on your own. As soon as you're ready, click play. But I want to see if you can come up with these answers on your own without any help. The first one, you should have came up with prime. That's the real answer. If you just said it wasn't possible or not factorable, you would be correct as well. Basically, what I'm trying to say is there aren't any binomials that will multiply to this, because you can't think of two numbers that'll multiply to a 2 but add to 9. The only thing that multiplies to 2 is 2 and 1. So the biggest you can add up to would be 3. So this is just not factorable, and that's what I was hoping you would come up with. But the correct answer for something that's not factorable, you would just call prime. Now the second one is actually a two-step problem. If you go back to our last video on factoring, you first learn how to factor out a GCF. So the greatest common factor of 2x squared, a negative 14x, and a negative 36 is a 2. And what happens is you are left with an x squared minus 7x minus 18 on the inside. So then you need to factor the inside, and only the inside. We're just going to leave the 2 out here. But what you're going to do is ask yourself what two numbers will multiply to a negative 18 but add up to a negative 7. And that would be a negative 9 and a positive 2. So negative 9 times 2 is a negative 18, but a negative 9 plus 2 is a negative 7. So if you got that one all on your own, good job. That was a step up. But that's it for this video on factoring. This is Longo, and I'm out. See you, bye.